Let me start with just a couple of logistics things, this time very quickly. So for that, let me share my screen. Okay, a reminder that assignment is due on Monday, 8 a.m. I'm reminding you now because basically our next class is after that deadline. So make sure that you submit as you go. There is no excuses for being late. The solutions will be posted a couple of minutes after the deadline. So solutions will not be accepted. Submissions will not be accepted after that. And really there is no reason. As you go every day, once you stop working on it, you just submit what you have. There is no penalty for that, just the last thing. And actually all the version will be saved, but nobody's gonna look at them. It's for your own safety, if you like. Only the last version before the deadline will be graded. Okay, so make sure that you submit your work way before. And in fact, as I said, submit it every day once you finish with the part that you were working on. Okay, another thing is the office hours. I hope you've seen that the office hours have started. If you go to the course webpage on Brightspace, on the left-hand side here on the table of contact now, you will find office hours Zoom links. So all the 13 TAs and myself have office hours. So you're gonna, you just go and pick a day and get it, which by the way reminds me, this doesn't really include weekends. Weekends, it's very important to start early working on your assignment because as in life, you can't expect people to be working on the weekends. You're lucky this time because there was a TA who actually preferred to work on a Sunday. So there is one slot on Sunday, but in general, while you do have a weekend before your deadline, it's really not advisable to start that, especially if you are not super confident that this is something you know about. It's going to be easy for you. Okay, so if you want help, make sure you start now, like right after the class. That's my advice if you want one. Okay, so that's all I wanted to say for the admin stuff. If you have any questions right now before I start teaching, I will let you unmute yourself. So are there any questions? Okay, in that case, I'm going to start today's lecture. So here's what the plan is. I'm going to, as promised, show you during the class how to document your functions, to write so-called docstrings that it's a part of your assignment. So even if you finished your assignment, just go back and add this documentation into each function. So these are so-called docstrings. So today during the class, I will explain what are the mandatory parts of the docstring. They're basically 3 parts, all super short, but it comprised, the info should have three pieces of information, if you like. But before we get there, I would also like to make sure that we really understand how functions run in Python, how Python executes programs, how are variables created, what about the variables that are defined inside of the function? Do we have access to them, to local variables versus global variables? So let's look at the simplest functions possible to one that we did in I can't see top of the screen because of the, do you want to save? No, this was our answer. Oh, by the way, that reminds me, if you have questions about the assignment, go to discussion board and ask your question. There's already 33 threads and 115 posts. I answered all the questions. So in the meantime, it looked in the last 1 hour, there's 3 new questions that I haven't seen yet. So this is the place for you to get valid information about the assignment, but do go scan through the question to see if your question hasn't been answered already. Okay, so again, like anything else in life, I will try to answer all the questions during the week or the weekend. It depends on the rest of my life. Okay, so do take advantage of the resources that are there. That includes all the office hours. The TAs will be there on Zoom link, whether you show up or not. They're going to be paid whether you show up or not. So do take advantage of these opportunities to get either explanations or help and so on. Okay, so let me open idle and get rid of these distractions. In fact, go to the class and open a code that we already did in class. All right. So we already did this in lecture 3. We immediately started with functions because basically you shouldn't write ever code just in the main. I'm going to explain what I mean by the main. You don't write spaghetti code. You break your problem into pieces. Each piece you solve it in a little function. So you use so-called modular design. It makes it more easy to test. There are many advantages, makes it more easy to test and write correct code, to test pieces that you finish. It makes it easy for others to use your function and so on. Okay, so we had two simple functions that we designed in the first lecture on the function design, which was area of a triangle and area of a circle. Now that you have seen input function in the last class, let me start by actually writing a first real program. What do I mean by that? When we run this, as you have seen, nobody has made call to this function. I'm having some indentation errors. Let me move this so I actually can see it. Okay, so let's see what my error is. Hopefully that got rid of it. As you can see, nothing really happens. The Python just learned that this function exists, but it doesn't, nothing really happens. In order to use this function, we were calling them in the shell. But if you were, let's say, writing this program for a primary school student, you wouldn't tell them load this, run this, and then go to the shell and then make function calls. I mean, this is not how you expect non-programmers to use programs. Normally you have your program communicate with the user. So we learned how to do this last time. So let's write something that actually looks like a code. I'm even going to return this. Let's say you were asked to write a program to help so that the pupils can, you ask them for the, oh, actually, let me leave that the other one because it has less variables. So you can compute the area of a circle given a radius. So what you would do first, you would ask a user or a student, enter the radius, something like this. Okay, and you would store that in variable radius. I mean, you would store it in any variable. I'm going to call it radius because that's a meaningful name for the variable. Okay. After that, you want to compute the radius, but we already have a function. We already designed a function that does that for us. So all we have to do is make a call to the function and send the value to the send the value to the function. Okay, so the user is going to input a value for the radius. It gets stored in a variable radius, so we make a call with that value. The function area of a circle is going to return a value which represents the area of a circle. So we want to store what it returns in a variable. I'm going to call this variable area again because that's a meaningful name for that. And finally, we're going to print a message to the pupil using a nice formatting, or at least a nice sentence, saying something, the area of the circle of radius. Now you want to put down an actual radius that I enter, right? So we start with a string, and then I put a comma, and then I give actually value of the radius that I enter. So I continue my sentence. Now I want is, and that's a string, and then I want to display what is an actual area of that. What is an actual area of that circle? So let's see how that works. All right, enter the radius, 22.5, and I have a mistake. All right, hopefully you saw the mistake as I was typing. If not, let me remind you something and emphasize. Let's see what happens. First of all, you can, let's read the message, what it says. It's unsupported operand types. We are trying to do a power on a string and an integer. So where in the code are we trying to use a power? It's here, radius, radius squared. That's what we're trying to do, and it crashed because it seems 2 is an integer, so radius to 2, and it seems radius is a string. And indeed it is. Because this radius here that we send, whatever is stored in this variable radius is sent in this function call. So here's the point to remember, something I emphasized in the last class, which is that input function always returns a string. Even if the user enters something that is a number, input is going to put quotes around it and return it in the form of the string. So in our case, we entered 22.5, and actually radius, what is stored in radius is a string 22.5. And here we are trying to then do 22.5 squared. Okay, so that means that since input function always returns a string, if you really want to string and work with a string, perfect, you're gonna get a string. If you don't want a string, you better do something about it. In our case, we obviously want a number because we're gonna do some math operations with it. We want radius to be a number. We have seen how to do this in the last class. We either convert to an integer or we convert to float. Which to use depends really on the problem that you're solving and what is meaningful for the problem at hand. Well, in this case, we should allow a radius to be either an integer or a float, so we might as well convert to a float, okay? So we shouldn't limit it to integers only. So here's a simple, one-line way to do it. Float, we've seen how to do it last time. Okay, so here I make a call to a float function, but before float function can execute, I have a call to input function here. Okay, so in order for floats to know what should I convert to a float, you first have to execute this function call that is inside of the parentheses. So input function is called, it's going to return string. In our case, it would have been a string quotes, 22.5 quotes. And then that string will be given to floats, and then actual number 22.5 would be stored in the radius. So let's try this again to see that this actually worked. So let's try again with the same thing, 22.5, and we get the answer. Okay, so this is actually our first full program that we wrote in Python. Let me mention a few things at this point. Okay, so let's try to understand how Python runs programs, okay? One thing is that Python is going to execute. In other programming languages, there is a special function that you have to call main. Okay, you have that in C, you have that in Java. And then when you click run on these programs, the program always starts in a main. So when you run these programs, it's going to look, when you look at the program code, the program is going to look, or whatever compiler or whoever is running the program is going to look first for the main, and it's going to start running the program inside of that function in the first line of function called main. There is no such thing in Python, at least not explicitly. Well, you can do it, but let's not get bogged down to this. Here's the proper program in Python. This one here doesn't have an explicit main function. What is considered the main is basically your program, right? If you're new to programming, this is what your program is. Here's my main program. So here's my main program. What do I mean by that? Where is Python going to start executing the program? The main for the Python are all the commands that are aligned with the leftmost edge of your file, right? So this one here, sorry, this one here, this one here, this is in the main, okay? So this is lined up with the leftmost edge of your program, okay? And in fact, usually, colloquially at least, you don't consider your function definitions to be the main, although they really are. So let's label this, here's where my main program starts. But in fact, it starts, all of these lines that are lined up with the main are actually a part of your main program, if you like. And in fact, one way to see functions as actually being a little separate programs. They're not going to be run. And we're going to see that in Python Visualize. So those who are new, please pay attention to that. This causes problem for the students who are completely new in understanding of functions. A function like this, just think of it as another program, a program called area of a circle. And when you need it, it's like, I'm going to call that program now. Okay, so you have a main program and think of function definitions as, in a sense, not being part of it, as being little separate programs that are going to only run when you call them. Okay, so let's copy paste. Let's go back to Python Visualize. And by the way, as you are doing this assignment, and if you're having trouble with some function, do this. Copy paste your function and make a function call in the main right after that and run it in Python Visualize. In addition to using it to understand how Python executes programs and how, which is basically the same. In all the programming languages, you're going to learn a lot about program execution. Later, you're going to learn a lot about memory, how memory works. But it also going to help you debug and understand what's going on when you're running your programs. Well, it's not going to really help you with syntax errors. But if you have a different type of crashes, like we just did, you will see exactly in which line crash happened, right? Because line before will be executed one by one. Okay, so let's look at the Python Visualizer. So you put Python Visualizer in Google, it's going to take you to this web page and copy paste this code. And let's see what happens when we run it. Okay, so as promised, what do we have in the main? We have all these lines that are lined up with the leftmost edge of your file. As we have seen this already, Python starts in the first line when it sees the command lined up with the leftmost thing. You will see now, so the red line is telling you what's going to be executed next. Okay, so let's execute it. So the main is going to start running. So let's see what happened. All right, so notice this square here. All right, it's labeled with global frame. That's the same as the main. It stands for the main. So each one of these boxes that you see under frames, forget what frames mean really, but each one of these boxes represents, if you like, a program or function that is running. Okay, while in Python, main is not a function per se, you can think of it as a function. So right now, main is running. It doesn't say main, it says global frame. It's the same thing, right? So if you prefer in your head, replace global frame with a main. So main program is running. This box here is showing you what the main program is doing. So it's running and it just learned that I'm gonna use math module. So make a note for ourselves to load math module things. Okay, now it's going to execute this line, all right? So it moves to the next line of the program. What's the next line of the main? Is the next line that is lined up with the leftmost edge. There was nothing in line 2, so it moves to line 3. Okay, we have seen this in one of the previous classes. Ask yourself, so do these things as I ask you as we go. I see your hand. Once I finish this, then I'm gonna get to your question. Okay, so ask yourself, and answer it for yourself. This is just for you to see how well you're understanding so far material. Ask yourself, where is the red line going to move next? So we are executing, the main program is executed, the command lined up with the leftmost edge are in the main. Okay, so Python is going to learn by executing this line here. Python just learns that area of a circle function exists. Then it moves to the next line. Nobody called this function yet. The function executes when somebody called it. So here, this is not a function call, okay? This is function definition. Python knows it because it starts with a def, so it didn't execute function call. Therefore, the body of the function is not executed now. You move to the next line in the main, which is going to be, oh, it's asking me for input, okay. Which is going to be line 8, because this is comment. 7 is a comment. So the next line that is lined up with the leftmost edge. Okay, enter the radius. What did we have? 22.5. So I submit. All right. And you see what happened. The input returned 22.5. Float turned it into a number. And actually what gets executed at the end is a radius is equal to 22.5. Okay, and you see what happened. Variable radius is created in the main. It belongs to the main. Every variable that is created in the main is called the global variable. Everybody has access to it, including the functions. So this is the global variable main. Okay, it belongs whenever you create a function, whenever you create a variable, and you're going to see that in a minute, a variable gets created in the space of whatever function is running. Currently, main is running, so this variable radius belongs to the main. Okay. So now we're in line 9. Line now, red line is telling you line 9 is about to be executed. This is assignment operator on the right. So you always go to the right-hand side of the assignment operator. What do we have here? What we have is a function call. So for those who are new, please make a big distinction in your mind between a function call and function definition. Function definition, which is this thing here, just tells Python what to do should somebody make a call. And you know that something is function definition because you start with a def and then you have a code that should be executed if somebody calls it. Function definition is always, you just have the name of the function and then you send 0 or more values depending on what that function needed. So this function needs 1 value. And what's in radius is 22.5. So this radius here is going to be replaced with 22.5. And then we have a call, area of a circle 22.5. So what's going to happen now? So here's what I want you to pay attention to. The main program was running, or main function if you want, but the main program was running. Now it's calling another function. So the main is going to pause, because it has to wait for this function to finish in order to get some value to assign to variable area. The main has to wait for this function. So you will see that the main in turn white, and in this Python visualizer, that means I'm pausing, and you will see that the new square is going to get formed to indicate that the function, this little program, is going to start running. Again, imagine a function call as if you're pressing run on some other little program, a little program called area of a circle. That's what function call does. It calls another function, that function starts running, like a little program starts running. All right, so let's see it. So let's see what happened. As promised, the main paused, it's white. This one started, so the function started running. It didn't exist before. I mean, it wasn't running before. That program wasn't running. Area of a circle is running. Let's understand this. Look, it looks like there are 2 variable radius. It looks like there is, you know, that there should be a confusion. It looks like that there are 2 variable radius. Indeed, there are, but there are no confusion. This is a radius function, local variable that belongs to area of a circle function. This is a radius function, radius variable that belongs to the main. So how did this variable get created? Remember, this here is a variable that you need to capture the input that somebody calling your function gives you. For that, you need a variable. That variable has a special name called parameter. So radius is a parameter in this function. Whenever you make a function call, the first line that gets executed is a parameter is equal to whatever value is sent here. So what was the value here? It was 22.5. So what gets executed first is radius is equal to 22.5. So the function starts, it looks at its space, it says, I don't have a local variable called radius, so it creates it and assigns 22.5 to it. Okay, so then so now this function area of a circle is running. The first line is done, meaning radius is equal to 22.5 is executed. Then we go next. Now, actually, this function is running, so we are going to execute its body. Okay, so next line is going to be 4. We do radius square times pi. Okay, you may wonder which radius it's going to use. Imagine that in this radius here, something else was going on in your program, that in this radius here, you have a 10. So there's one radius that says 10, and there's another radius that says 22.5. And you come to this line, and you should do radius square. And you wonder which radius should I squared? Well, it's radius of the function running. So you look for the variable radius inside of the function running. Only if you don't find radius in the function running, you go to the global frame to see if radius is there. So if this was 10 in the main and this was 22.5, you would still use 22.5, right? So you're using the radius variable of the function running. So it's going to compute that. Once it computes it, it stores it in variable areas. So it's going, therefore, inside of this function that is running, it's going to create a new variable called area because we don't have that variable. Okay, so that we are done with line 4. Now it's about to execute line 5. Okay, so line 5 returns a value. Okay, so you will see now, just as I promised, calling a function is like calling a little program. This little program is running. This little program is at the end. When you encounter a return statement in a function, the function returns a value and ends and terminates. So you will see when I press next that this blue square, so basically it's going to disappear. That program, that function stops running. It returns this value to the caller. So who called this area of a circle? It was the main that called. It was the main. In fact, in line 9, it was waiting here for whatever the area of a circle returns. Okay, so it returned 1590. Okay, so that value is going to be returned here, and main will execute area is equal to 1590 plus. So when I press next, notice that this function ends and returns the control. So main gets unpaused. It continues, it works. Okay, so main is now blue. It was waiting, but now it doesn't have to be waiting. It creates its own variable area where the result that this function return is stored. And now we are at the last line, it prints the function. Okay, since I now explained how this run, it's a good stop to take this one question that I have from Monica. Monica, I'm not going to take 10 questions. Let's start with one, and then I'm going to make a pause, and you guys can ask a question. So Monica, go ahead. You can unmute yourself. Oh, maybe you can't. Now you can. Unmute yourself.
Hi, can you hear me?
Yes, I can hear you. Go ahead.
Okay, so at one point you said you can enter 10, you can enter 22.5, but it doesn't matter, it'll still take the 22 point. What did you mean by you can enter 10, whatever, and it'll still take 22.5? Like, what does that mean?
Can you repeat? I didn't really understand the question.
So earlier you said even if you enter 10 or any other number, it'll take the 22.5.
No, that's not what I said. No, that wouldn't make any sense. I agree. I agree with that. Let me just say what I meant here. In this example, what I was saying, enter input 22.5, submit. All I was saying, when you look here at the right-hand side here, imagine that is what is stored in this variable radius is 10. And that what is stored in this variable, so you forget the program, I'm covering it with my hand as if it covers it for you. Forget the program on the left. Look at the picture on the right. Imagine that the next line you have to execute is radius square. And imagine that what is stored here, what is stored in radius variable of the main is 10. And what is stored in the radius of this function is 22.5. And imagine next line that the program is going to execute is r squared. I was asking you what is going to be squared, 10 or 22.5? If all of these, both of these variables have the same name.
Oh, I see. But where did the 10 come from? I'm just confused.
It doesn't matter. I can cook up a program that you end up in that state, right? That you end up in that state.
Oh, I see. Okay.
I mean, it's easy. Here, I'm going to give you a stupid example of that, actually. Here, I'll cook up something nonsensical. I'm going to do this, but I'm not going to actually use it. I'm going to do 22.5. Okay, so let's see what happens now. So you have two variables, both called radius. You're about to execute this line that says radius squared. What number is it going to, which radius is it going to square? There's radius here and there's radius here. I wanted you to understand that currently is the function area of a circle running. There is no going to be confusion for Python which area, which radius variable is gonna look for the value. It's gonna look in the radius variable of the function currently running. So function area of a circle is running. It's not main that is running. So it's going to square 22.5.
Oh, I see.
Okay, does that make sense?
Yeah, that's perfect. Thank
Okay,
you.
I was just trying at the same time to explain both the executions of the program and how variables work, right? So it could have been confusing. All right, so if I go back to, and I want to ask you a couple of questions about this so you can test your knowledge. They're not going to be as obvious, let's say, for some of you, as this one may have been obvious, but let's see. But before that, let me go back just to this code for a little bit and remind you what a parameter is and what an argument is, because these are the terms that are used in all programming language books, and you need to understand it because there's a conceptual difference, not in the word you use, but in the function they're performing in the program. So when you're defining a function definition, you ask yourself, does my function to do its job needs any data or any values from whoever is going to use it? And in terms of area of a circle, the answer is yes, I need a radius. I need one value. I need you to give me a radius. So whoever is going to call a function is going to send you a value, okay? That value, you need a variable to store that value. So here we've seen this already in a function definition, you're going to put a name of one variable. So the radius here, the variable to capture the input, to capture the number or value that somebody is going to send you, that variable has a special name. It's called parameter. Okay, so in function definitions, what comes between the parentheses are variables or parameters. Okay, when you're making a function call, you're always sending a value. Well, unless it's one of those functions that doesn't take any value. In our case, this function, when you're calling it, you are sending a value, okay? So if I ask you, what is radius here? So I highlighted this radius. If I ask you, what is radius here? Your answer is the role of the radius there is that it's parameter. So it's a variable, it's a parameter. Radius is a variable. If I ask you this radius here, what is its role? Is it a parameter? No, because what is stored here in this radius, in our case, it was 22.5. So what de facto happens with this call is that the radius gets replaced with a value. So we are in a function call, you are always sending values, okay? So, but you're not gonna hard code it. I need a variable to store that. So this radius here is actually playing a role of an argument. It's sending a value to the function, okay? So this here is a variable, it's a parameter. This here is an argument. I'm sending whatever value is stored in radius, I'm sending it to this function, okay? So in our case, it was this. So when the function gets executed, what is the first thing that happens always is that you take the first parameter, what gets executed. Here's what gets executed whether you want it or not. First parameter is equal to the first argument. If you had another parameter, it will be second parameter is equal to the second argument. That gets executed first when you make a function call, whether you want it or not. So when the function starts running, in this case, it's going to execute radius. So the first parameter is equal to the argument for the first argument, which is 22.5. Okay. So, by the way, here in this print function, we can see all these values that are sent to print function. If a function requires more than one value, you always separate them by commas. So for example, this print call to the print function has actually 4 values. First, you're sending a string, then you're sending a number, then you're sending a string, then you're sending a number. So we have a call to the print function that it's sending 4 arguments, 2 strings and 2 numbers. All right, so let's look at another example. So, answer this for yourself. Edit code. All right. So actually, let me start with something super simple. Print x, x is equal x plus 1, print x. So let's see, what does this? I didn't have to do this in a visualizer, but anyways, so everything is in the main. Variable s gets created, it gets value 10, we print it, so it prints 10. Now here we have this expression which mathematically makes no sense because you would be reading this as an equal, but this is not equal. Remember, it's an assignment operator, so you go to the right-hand side, you do whatever is an x, add 1 to it, so 10, what's in x is 10, 10 plus 1 is 11, and then you do assignment, right? So assign 11 to x, so 11 will overwrite x, and now x is 11, so this program writes 10, 11. Okay, let's look at something a little bit different, just slightly different. Def Okay, so everybody, try to answer this question for yourself. What does this print? This goes to me trying to see that you understand both how the programs run and how variables work in programming languages, okay? So this is really just for yourself to see if you're getting it. Of course, you can copy this into idle and see what it does, but what's the point of that? This is for you to figure out, are you understanding this material? So just answer it for yourself. Take a minute, I'm gonna take a sip of water. Okay, so hopefully you all have your answers. So let's see. Let's see, first of all, in Python, let's see the answer. Okay. All right, it prints 10, 10. So let's understand why. So especially for those who think it prints 10, 10, or also those who guess right, but they're not exactly sure why the answer is as such. So, all right, it really goes back to what I explained previously. So let's see it at works. So as promised, after the first line is executed, the main starts, which is labeled here as a global frame. Python learns, this is a function definition. Python learns that increase function exists and moves to the next line in main, which is for, okay? It doesn't execute the body of the increase function because nobody called it yet. So it moves to line 4, we say global frame main started running, it knows function x exists. Now it executes x is 10, creates integer 10, creates variable x in the main and stores 10 in it. Now it prints x, so this is going to print 10. Now we have a function call. So the main, again, pauses, and this little program increase, a function starts running. What is sent to this parameter x? So remember what happens when the first line of a function call gets executed, its parameter, what gets executed is a parameter. In this case, parameter is x, is equal to whatever this value is. This value is 10, so x is equal 10 gets executed by the function, okay? So the next line is this. So main pauses. Now increase is running, which is indicated by this blue box. X is equal 10 is executed. Remember in Python, x is equal 10 creates a variable 10, except that this time, this is a variable x that belongs to a function increase. Since we call the function, now the function body is going to get executed. So we go to line 2. Okay, this line gets executed. And so basically you execute x plus 1, which x of the function running. So it's this one. But in this case, both are 10. So 10 plus 1 is 11. So 11 is assigned to x. Which x is 11 assigned to? This one here in the main or this one here in the increase? It's the x of the function running. Okay, increase is running, so its x gets executed, increased or changed to 11. X in the main, nobody touched. Okay, no value was assigned to x in the main, right? Notice now something that we were learning in previous classes. The function ends either when you encounter a return statement or you come to the end of the code of that function. So there's no lines in the body of the function. We came to the end of the function. If the function doesn't have a return statement, what you notice here, we don't have a return statement, yet Python executes return none. So that's one of those things, again, is going to happen whether you want it or not. So the functions that don't have return statement, they're gonna terminate when you come to the end of the code body of the function. It's gonna terminate and it's going to return none, okay? So this function is not going to return anything. So when I press next, hopefully you know that it's going to move to line 7. So basically this increase function will terminate, it's gonna disappear. The control is returned to the main that was waiting. The main was waiting, which is indicated here. So main can continue because this call was done. Okay, it's gonna continue in line X. It's gonna say print X. Which X? Well, my own X. Main is now running. Its X is still 10, so it prints 10, 10. Okay. All right, so now last example about this, and it's something that you will use in your assignment. So I wanted to show you how it actually runs. You were asked to do it in your assignment. So here's an example. Again, it's one of those I'm gonna ask you to answer for yourself what it does. Not what it does, what it prints. Okay. So let's see what we have here. We have two functions. The first one, function definitions. The first one is called add 3. You give it, it expects 3 numbers in input, it adds them up and returns a value. Then we have another function. It's kind of artificial one, I admit. It's called times 3 because simply you give it a number, it's going to multiply it by 3. All right. But there, when I went to code this function, of course, I could have done return 3 times W. It's going to multiply W with 3. But I already had this thing that adds 3 numbers. So another way, equally correct, convoluted, but equally correct, is to call that function, give it 3 times the same value W. So when you do W plus W plus W, that's the same as 3 times W. Okay, so we call this function to compute 3 times W. And we store that value and return it. So we come here and we have a call to this function here. So answer for yourself, what do you think this thing blah prints? There's only one print statement. In this case, since I explained it, you're likely to guess correctly, but what I want you to see is how this function call each other, who returns to whom, what value. So take a minute to answer this for yourself while I take a sip of water. Okay, so you could guess that if this is correctly computing something times 3, that this should be 2 times 3, 6. It does print 6 if you copy paste. But let's now understand how this runs, because this is really what I wanted to show you. All right, visualize execution. As before, once the first line is executed, this part here is going to show you main running. Okay, so what belongs to main? It's all the lines that for now, simple explanation, all the lines that I lined up with the leftmost edge. So it's going to execute just this first line here to learn that function add3 exists. Then it moves to the next, again, nobody made a function call, so these lines are not executed, 2 and 3, not yet, not until somebody calls them. So it moves to the next line lined up with the leftmost edge, and this is this one. This line defines a function, or at least telling you that there will be, that there is a function called times 3. Should somebody call it, you shouldn't complain because there is a code for that, so run it. Okay, once this line 5 is executed, ask yourself, what's the next line that's going to get executed? All right, as before, it's the main running. Nobody calls this function, so it moves to the next line lined up with the leftmost edge. Main is just a comment, so it's going to go to 9. Okay, so now something starts happening. On the right-hand side here, which is the first thing that's going to get executed, because you go to the right-hand side of assignment operator, you have a call to this function, times 3. As we already seen, the main will pause because it needs to wait for this function to return it a value so you can assign it to blah. Value 2 will be sent to W. So in other words, Python is now going to go, because we called function 3 times, we look where it is, so Python is going to jump to line 5. And it's going to execute again, whether you want it or not, W is equal to 2. Okay, so you will see, there you go, main post, this little program or a function, times 3 starts running, it executed, W is equal to 2. So you have this local variable, so variables that are created by the functions when the functions are running called local variables. So variable, local variable or parameter W gets created because W is equal to gets executed whether you want it or not. So first parameter is equal to first argument gets executed. Okay, so now this function is running, so we should execute the body of that function. Somebody called it, now we should actually execute its body. So we go to the line 6. We have an assignment operator. You always go to the right-hand side of the assignment operator. There we have a function call again. So before we can assign anything to this variable p, this function has to return to me some value. So the function 3 times, the one currently running, has to pause and wait for this function to complete its work and return a value. So now you will see not only main is paused, but also 3 times, this times 3 function will pause and the function add3 will start running. The call that will actually be executed is add3. What is W? 222. So we now execute a call add3 222. So the function add3 is going to start running, times 3 is going to pause. So we do next. You see it, white functions, the main times 3 are paused, and add3 starts running. What gets executed is first parameter, which is x. So what gets executed is x is equal W. W was 2. X is equal to gets executed. Second parameter is equal to second argument gets executed. So it's y is equal to 2. Third argument equal to the third parameter equal to third argument gets executed. So you get z is equal to 2. So we get these variables, x is 2, y is 2, z is 2 in a function add3. So now this function continues running. Right-hand side, add these 3 numbers and assigns it to t. So variable t gets created. Now this function is about to return whatever is stored in t because it says return t. Whom does this function return value 6? It returns this to the caller. Who called add3? It was the function times 3 that called. In fact, it called it over here. So what's going to happen when I press next? Remember, when function encounters a return statement, it terminates. So the little program called add3 now stops. And the caller resumes. So times 3 is going to resume. It was waiting over here for a value that this function will return. So the red line will move basically to line 6 or 7, well, 6 because it's going to execute 6 and then move to 7. Okay, so you will see this function that is running is going to disappear. Value that it returns 6 is going to be stored to P because times 3 was waiting there for that value. So now it can execute P6. Now we have returned P, which P, well, this one in the function running, it needs to return that value. Whom does it return it? So who called times 3? You can actually look up. This is so-called stack, but I don't want to go into more details. But if you're looking in Python Visualize and you wonder who called times 3, you look up and the box above you called you. So this is global frame, it's a main. So main was waiting over here, it called times 3. So when I press next, times 3 function will terminate and value 6 will be returned here. So main can finally resume. So blah is equal 6 gets executed and we print blah. Okay. So in one of your questions in the assignment, it said in description what it should do, it said this function should solve blah. And to do that, you should call the function that you already designed, a function from a previous question. So for example, here we have that this function is calling the function here. Okay. All right. So what I'm going to do now, Monica and Ala, I'm going to take a question towards the end of the class. What I want to make sure is that we cover docstrings. So in the last 20 minutes, now we are going to cover docstrings, or documentation of the functions, because you will have to document every single of your function with docstrings. That's required it's in specifications for your assignment. So let me explain that, then I'm going to take your questions. Okay. All right. So, and remember your questions, write them down if it was about this, and I'm going to come back here. All right. Especially keep your questions to the end if they're about the assignment. We're not going to do questions about the assignment in the middle of the class. Okay. So let's see. I hope you remember. So actually, I don't want to be doing increase thing anymore. What's here? All right. Ooh. All right. So let's go back what we had at the beginning. No, not that one. Sorry. This one. Okay, let's write documentation for these 3 functions. They're not necessarily the same. Let's actually start with this one here. All right. So, and let me make it such that you can see both the shell and the code. At least that I can see both the shell and the code. All right, so, okay. So remember when we looked at Python functions, built-ins, okay, and we wanted to know what something does. Let's say, all right, let's say, let's look at the simplest one, ABS. If we wanted to know what it does, we got some information on what the function does. First of all, return the absolute value of the argument. So if you give me, remember, even here they use it. Argument is just a value that you give me. I'm going to return an absolute value of the given value, so of argument. So you're going to give me one value, I'm going to return an absolute. So your documentation, first of all, should have what the function does, like one sentence, right? And as I said, the help, it used to be actually in previous version of Python, they had extra information of what type of data they expect, but somehow it looks like they were a little bit lazy with the newest versions. But the point is, let's see what happens with our own, why did now, okay. Open the new shell. All right, sorry. Okay, so, all right, so if we did help ABS, it gave us useful information, help power, so they all had nice, fairly useful information about how do you use their functions, right? For this one, it's telling you that it's going to return base to the exponent, and that there is one voluntary third piece of data that is not mandatory. Okay, but let's try to do this with our own function. Let's see, first of all, if it's going to crash, if I want to do help on my own function. Well, a nice surprise that it doesn't crash, but it doesn't give much useful information. In fact, Python just gives the only information that it has, which is that your function has a name, area of a circle, and that it expects some value, one value as an input. Okay, it has one parameter. That's all you know, because basically just copied your header. That's all it knows. Okay, so there is a way, so here's a way to document Python's function. For that, you use a third type of strings that we haven't seen in the last class, or third type of way to create strings. You have seen the last time that you can create a string in Python by starting with a single quote and ending with a single quote. You can start also by starting with a double quote and ending with a double quote. And you can also start with triple quote. What's a triple quote? 3 single quotes, and then end the string with the 3 single quotes. And in fact, that one is quite useful. And here's why. Remember when we were doing something like, we could create a string, this is a string. Okay, so that was easy with the single quotes or double quotes. But if we wanted to have a string that goes across multiple lines, and when I was doing this is line 1 and I want to go to new line and press enter, Python's going to give you syntax error because it expects actually that you close the string, okay, and you didn't, because these single quote and double quote strings are meant to be in one line. Okay, so enter is going to give you a single, it's going to give you pressing enter is going to give you a syntax error. So let's see what happens when we are doing it with triple quotes. So S is equal, so 1, 2, 3, it's 3 single quotes. This is line 1. Then I press enter, you see no crash. This is line 2. This is line 3. Okay, I had enough of this 1, 2, 3, and we created a string. So remember, when you put a variable name in Python shell, Python tells you what's stored in that variable. This is meant for the programmer, okay? For that reason, it's telling you, the programmer, that the characters in this string are, this is the line 1, then /n for the new line. This is line 2, that's /n for the new line. This is line 3, okay? Only if you print it is going to display it in a humanly pleasing way. Actually, meaning when it encounters /n, it's going to go to new line. Okay, so nothing much new except that now you know that in Python you can create strings by starting with a single quote or double quote and triple quote. An advantage of triple quotes is that you can go across multiple lines. Okay. So in Python, you put a documentation of function using these triple quotes by putting a string describing what your function does at the very beginning of the function, meaning as a first thing in the body of your function. So we go here, it's right here. And I'm going to show you what's the advantage of that, because actually it's going to show up in help commands. Okay, so you're going to put the comments, you do triple quotes. I put the triple quotes again just to close it off in between here, and you can go to new lines. Okay, here you're going to put the documentation of your function. All right, so obviously documentation throughout this semester is going to be comprised of 3 pieces of data that you will have to put. Okay, the main one that I want to see, and that the students have most issues with, but the main one I'm insisting on, because students need to understand the type, all right? Because Python, you don't declare the types. It causes various issues for the students who didn't come to Python, who didn't study other like strongly typed languages. I want to make sure that you understand the type. So first thing you're going to have to write is so-called type contract, okay? So here's what the type contract is. You look at your function definition. You look what's between the parentheses. You see how many parameters you have there. In this case, one variable. That variable is going to receive some value. Okay, so before I tell you what go there, let me run this. And you say, okay, my function is completely correct. It's, you know, unbreakable. If I do 10, it computes area of circle correctly. Not 10, 2. Let me do it again. Okay, if I do 2 like this, it crashes. Okay. And it's nothing special about mine. If you do this, it works. If you do ABS 2, this doesn't work. Okay, so there is some assumptions you're making when you're making your program. Okay, your program or your function may crash if your assumptions are not met. Okay, so what did I do here? Okay, so type contracts is a contract between you and a user when you tell a user, if you give me this type of data, okay, I promise not to crash. And I promise to return you blah. Okay, let's see what I mean by this. So what do I expect for the radius? I expect a number. If I know that only integers make sense, I should put an int here, all right? If any number makes sense, then I should put just a number to indicate that it's either a float or an int. In this case, we really shouldn't limit area of a circle to be computing area of a circle only on integers, so I'm gonna put number, okay, to stand. You can use either integers or float. So I have one parameter. For each parameter, you should specify what type of data do you accept and for which you promise that your function is not going to crash. I look at my code and I promise it's not going to crash if you give me a number. And then I make a promise that if you give me a number, I'm not going to, not only I'm not going to crash, I'm going to give you what back. I'm making you a promise what you're going to get back. What goes here, all right? You look at your code, you're doing now, you look at your code and look, is there a return statement? Okay, in my case there is. Then you ask yourself what type of value, what type of data, what data type I am returning. In this case, area is also a number. If radius is a number, if you give me a number, I'm gonna give you a number back. So I just put, I'm going to return number for you, all right? So your type contract is going to have types of all the variables, all the parameters that you have in your function header, and it's going to have a type of data that you're returning. Okay, so this is a type contract for this particular function. If you give me a number, I'm not going to crash and I'm going to give you a number back. That's the contract we are making. That's why it's called type contract, okay? So that's one thing to do. Then the other thing is the obvious one that you saw in help pages, that you write a line saying, what does the function do? What does this function do? Okay, that's easy. Returns, the function returns the area of a of the circle of a circle or this circle. I'm never sure of these things. Of the, okay. Of the given radius, okay? That's what the function does. Okay, so don't mix two things, promising that you're not gonna crash with promising that you're gonna give a meaningful and correct result. Okay, what do I mean by that? We are almost done, but let's run this. All right, so area of a circle, 2, oh, it seems to be giving correct result, even if I give it a float. Okay, this seems to be working. Or does it always work? Does it always work and give meaningful result? Well, okay, we get area of a circle of negative radius. That's not a meaningful result, right? What does it even mean, right? So you only are promising to give a correct and meaningful result if a radius is bigger and equal to 0, okay? So there are two things you want to write. One is this, which is a type contract, which is when you're talking about what type of data is not going to crash my code. And the other one is called preconditions, which is your assumption on the input. So you want to say, I'm going to give you actually correct result, correct and meaningful result if you give me radius bigger and equal to 0. I'm making no promises about what it means if you give me a radius that has that is, if you give me a negative number. Okay, that's it. So that's a documentation you have to do for every single question in your assignment. What's the data type you expect for your parameters? What does your function return? Are there any preconditions? Sometimes you may not have preconditions. Sometimes maybe what you're doing works, it makes sense and it's correct for everything, right? Let's say your function is just returning a square of a number. Well, then it makes sense. There is no preconditions. You give me a number, I'm gonna give you a correct result. Okay. Now, look at this next thing. I'm going to give you a couple more examples because you're going to have various things in your assignment, okay? Where you're returning various things, have preconditions, not have preconditions, and so on. Let's look at this one here. But before I do this one here, which is basically the same, but let me change this code and have a function that just does this. Print area. All right, let's see, what do we do? Okay, so this is what our function does. Let's actually first write what the function does. Does it return anything? No. What does it do? It prints the area of a circle of the, I miss here, it prints the area of a circle of the given radius. Okay, that's what it does. So we are done with one of those 3 required parts. Okay, I still have this precondition. I still, if I wanted to print correctly the data, I better, you know, say that the radius is at least 0. Okay, let's look at the type contract. All right, again, what do I expect for the radius? Again, I expect the number. What did we say? So if you give me a number, I make a promise that I will return what? How do you determine that? What your function returns? I look at the code, I look for the return statement. This function does not have a return statement. Nobody asked you to return anything. You were just asked to print something. Therefore, there is no return statement. Remember that Python, that's what I was showing in Python Visualizer. Once you come to the end of the code of a function, if you don't have a return statement, before terminating, whether you want it or not, Python is going to return nothing, meaning it's going to return an object that represents nothing. That object is called none. So Python is going to execute this, return none, whether you want it or not. So in your contract, if there is no return statement, what does your function return? It's none. So I'm promising, if you give me a number, I'm not going to crash, I'm going to return none. And then here is gonna also, I'm also gonna print this, and given these preconditions, what I print is correct. Okay, let's do, this one would be, I mean, there is nothing to do, let me just do type contract trivially, which is base, I'm expecting a number, height, I'm expecting a number, and I'm returning what? I look for return statement. Area is also going to be number if base and a height are number, so type contract would be like this. Let's look at a different example. Let's say you have a function like this, def draw rectangle. Okay, so I'm going to have a function. Okay, I guess that can look like a rectangle. All right, so I have a function like this. It doesn't need any values. When I call it, it draws something that looks like a rectangle. Let's say this is a rectangle. Let's not go into in a previous class, I was doing this. All right, so I guess I can do it here too. Not that it's a much better rectangle, but anyways. So let's write docstrings for this function. Oh, by the way, I didn't show you the fun thing that when I was surprised of something nice when I learned this about Python, which is that this becomes, if you use triple strings to write your documentation and you put it at the beginning of your function, it becomes a part of the help pages, right? Remember the first time we did this, when I did help on this function, it didn't really tell me anything other than the name of the function that it has one parameter. But now all of this data is now part of the help pages, the data that you want to share with whoever is going to use it. So somebody, remember, when we did dir built-ins, or first time we did, when we did help ABS, when we did help on the power function, we don't know what the code looks like. We're not going to read the code, but we want to know how to use the function. So we just type help to get to learn how to use the function. I mean, do you want to read the code of the print function? Maybe eventually, not at the beginning, right? So you're not going to be reading what's inside of the function, but you can read the help pages, right? So if you use triple quotes and put them at the beginning of your function, then you get to, they become a part of the help pages, okay? If you use single quotes and double quotes, the second line is not gonna show up in the help pages. So that's a reason to use triple quotes. For those who program in other languages, if you use comments like a hash, it's not gonna show up if you're commenting with hashes in the help pages. So this is a really nice benefit of documenting function using strings that start and end with triple quotes. Okay, so let's go back to documenting this function. Let's do the type, well, actually, let's start with easiest one. What does the function do? Doesn't return anything. The function draws, or function, let's say draws, ASCII, these are called ASCII when you draw something with a keyboard character, ASCII square, okay? Function draws ASCII square. Let's do the type contract. So we open parentheses and look, are there any values sent to these functions? No values are sent. There's 0 values, so we don't put anything in parentheses, okay? Because it's for the values that you expect, for the parameters that are going to receive the values, you see what type of values you expect. You're writing what type of values do you want. Here, there is no values, so you leave the parentheses empty. And then you say, what do you expect, what you're going to return? Again, how do you determine what you're going to return? You look at your code. Is there a return statement? There is no return statement. This function just draws the rectangle and terminates. And again, Python, in that case, Python chooses, Python is going to return none, whether you want it or not. So the correct type contract for this function is this. Do you have any precondition? Do you have something where this function is not going to draw a rectangle? No, there are really no preconditions. So if there's really no preconditions, you're going to do what you said you're going to do, then there's nothing to write. So preconditions, you write them when you have them, okay? So your documentation is going to have 3 pieces of data, must have 3 pieces of data, type contract, preconditions, if any, and the description of the function. Okay, let me just give you one last example, then we're gonna end the class and get to the questions. Let's say you had something like this. Def foo a b result is equal to a less than b, return result. Okay, let's write, doesn't really matter what this function does, something something that is not even worth describing. Okay, so let's write a type contract. Let's see what this function does. We're actually comparing two things. So let's say that we really just want to compare two numbers. Okay, so I look at how many parameters my function has two, what type of data do I expect. I'm going to put numbers. Let's say, or you can do int. Let's say for whatever thing I'm using this, it's going to be int. Okay, so I'm expecting two integers. I want to compare them. Okay, so what's going to get stored in results? Okay, what will be, so it looks like I need to determine what does this function return. All right, this function returns whatever is stored in results. You look at what type of data. So you have to put data types. Okay, what type of data is stored in the results? This is a comparison operator. Result of comparison operator is always true or false. So these are Boolean values. So this function is going to return true or false. So what type of data it returns? It returns bool. Okay. Let's see a different example. What if we have just one value here and I do return, let me put it all directly in the return a plus, this is some text. Okay, so this is one line function. What does it return? Okay, first of all, what's an a? Okay, I want to make a promise that my function is not going to crash. Let's look at what this does. It applies a plus operator to a string. Remember in Python, so this is a concatenation operator. We've done it last time. So unless a itself is a string, this is going to crash. Okay, and I don't want it to crash, so I'm going to say a is a string. Okay, so if you give me a string, I'm going to return what? This is a string plus a string that actually does a concatenation, the result of which is another string. So what this produces is a string, so we return a string. So this is str. Last thing, because you have to do it in your assignment, when you are returning more than one value, remember somewhere in your assignment, for example, you'll have to return in two spots, you'll have to return two values, let's say P and T or P and O, you were asked to return something like this. In the return type, this I'm going to, depends on the question. In the return type, you can also put two parentheses and say P is going to be, I'm returning P as an int and O as an int, if that's what's happening. So you can represent what you're returning like this, or you can be less specific. If you're returning more than one value between two parentheses, that data type in Python has value, is called tuple. You are actually returning a tuple. And it doesn't really matter. You don't need to know more. So you can just put a tuple. If you're returning more than one value, we're going to get to tuples when we get to lists. So they're basically immutable lists if you want to know what it is. Okay, so I'm going to stop at this point. Those of you for whom everything is clear and don't have questions, you are free to go. Those who have questions, I'm going to let you unmute now and you can ask your questions.